Hi, Integrated Math 1. Welcome to lesson 4.1.2b. We're going to do the other half of our lesson today of Module 4, Topic 1, Lesson 2. So we're still looking at those measures of central tendency and also at how spread out our data is, right? And last time we were playing with the whole skewed right, skewed left, and so we were going with the median. And we're like, well, we're going to go with the median because it's a better measure when stuff is skewed a little bit. But let's come back to the mean, shall we? So here's the situation. Miss Webb is determining which student she should add to the spelling bee roster that will represent Tyler High School. The chart that we have over here shows the 10 most recent scores for 3 students. So here's Jack's 10 most recent scores, Aaliyah's, and Tymar's. She did go to all the trouble to make box and whisker plots. You don't have to make them. Ms. Webb already did. So the box and whisker plots display each of the students' spelling bee scores. So here's Jack's plot, box and whisker plot, Aaliyah's, and Tymar's. Can you take a moment and just describe for me the shape of each student's data set? Remember, skewed left, skewed right, symmetric. Take a look at the shape that we've got going on here. Hit pause, write it down, hit play to keep going. I don't know about you, but these look really symmetric, right? These data sets look super symmetric. They're not leaning one way or the other. This is kind of like right down the middle, isn't it? So we learned last time about the spread of data from the median. We learned that interquartile range helped us figure out the spread from the median. But these are nice and symmetric. So I'm going to go ahead and use the mean. I don't need the median anymore. We can do the mean now because these are nice symmetric box and whisker plots, nice symmetric data. So if you know the mean of a data set, you can calculate the spread using something called standard deviation. So your interquartile range helped you figure out how spread out you were from the median. Standard deviation is a measure of how spread out the data is from the mean. So it's a different measure of spread. Now it's measuring how spread out your data is from your mean instead of your median. So this is a great one to use if you have nice symmetrical data. You don't have that skewed left or right thing going on. So this is going to look freaky. Don't freak out. Don't freak out. This isn't hard. Don't freak out. I'm going to help you out. The formula to determine the standard deviation of a sample of your data in your population is represented using this. Don't freak out. Don't freak out. Don't freak out. You actually know what a lot of these things are. S is new. S is for standard deviation. I know you're shocked and surprised by that. Square roots, you know square roots. You know sigma. Remember, sigma is just summing the sum, right? The summation, we're adding them all together. So don't freak out when you see that sigma. You know that means you're just going to be adding a whole bunch of stuff together. That's all. X sub I is just each individual data value. That's why it has an I, right? So your first term, your second term, third, fourth, fifth, all that. That's all that is. And of course, you know what X bar is. We did that before. X bar is your mean. You know it. You know that you're going to square it. No big deal. You know how to square stuff. And we've talked before about how n is the number of data points, how many data bits I have. We have n minus 1. I hope you know what a 1 is, and then I don't have to describe that for you. So we're going to look at each part of this formula separately. We're going to break it down a little bit. There's actually nothing here that you don't know how to do. It's just a lot of steps. So we're going to break it down to try to help you guys out, okay? So first of all, let's say I've got this lovely data set and we're going to keep it small and we're going to keep it simple for practice purposes. So I have 6, 4, 10, and 8. First thing you need to do is you need to calculate the mean. That's the first thing. Well, first thing, put them in order. But we are going to calculate the mean. You know how to find the mean. You know that you find the mean by adding all of these guys up and dividing by how many there are. I have 4 of them, so I'm going to divide by 4. So we add these all up. 6 plus 4 plus 10 plus 8 means I get 28. And if we divide that by 4, I don't even need a calculator. It's 7. So X bar is 7. My mean is 7. Good. That's the first thing we got to find. The next is we need to think of each data value as its own term label. So this would be my first term, so X sub 1. My second term, X sub 2, third and fourth, and so on. Now remember that this little sigma guy means sum. It means we're going to be adding stuff together, and we'll deal with that in just a little bit. But you notice how within the sum, it said to subtract from the mean and to square it, right? This is what it said within that sum. So let's do that for each term. So for each term, you're going to subtract the mean and square it. So my first term is 6. My mean is 7. 6 minus 7 is 1. If I square it, I get 1. Next one. 4 minus 7 is a, what is that? 4 minus 7 is a negative 3. Square negative 3, you get a positive 9. 10 minus 7 is 3. Square it, you get 9. 8 minus 7 is 1. Square it, you get 1. So I just took each of these and I subtracted the mean. That's all I did. I took each one, I subtracted the mean, and then I squared it. Now, summation says you got to add them all together. So I'm going to take all of these guys and I'm going to add them together. 1, 9, 9, and 1. If I do that with my help of my trusty calculator, I get 20. On the bottom, it's our formula said n minus 1. Well, we know that n is 4. So 4 minus 1 is 3. And we use the lovely calculator. 20 divided by 3 is about 6.7. It's actually 6s going forever. You know how it goes. And last but not least, do the square root. Do you see why I said you need a calculator? You want a calculator? So if I do the square root of that, I get about 2.6. So the standard deviation for this data set is about 2.6. And it's important to note that if my data values have units of measure, right? If I was like, this is 6 inches, 4 inches, 10 inches, 8 inches, whatever it is, then my standard deviation would also use that unit of measure. So if I was like, these were in inches, then I would say that my standard deviation is about 2.6 inches. Yeah. Now, all this is it's just a measure of how spread out stuff is from my mean. So can you go back, take a look at those box and whisker plots, and answer this question? Do you think, remember, standard deviation is how spread out things are. Do you think the standard deviation for each student's spelling bee scores will be the same? If yes, tell me why you think they're all the same. If you tell me no, they're not going to be the same, predict who's going to have the highest standard deviation and who's going to have the lowest standard deviation. Hit pause, go back and look at those box and whisker plots, and then hit play to keep the discussion going. I'm going to come back to our box and whisker plots here. I'm coming back. So they were nice and symmetric, but we said standard deviation measures how spread out they are. I don't know about you, but Aaliyah's scores look pretty nice and tight, where Jack's is a bit more spread out, and Tymar's scores are like way spread out. So I don't think they're going to have the same standard deviation. I think Aaliyah is going to have a really low standard deviation, and Tymar, since he's really spread out, he's going to have a much bigger standard deviation. I'm sorry, I scrolled too fast. So no, I don't think they're going to be the same. I think Aaliyah's scores are going to have the least standard deviation. Hers is much more clustered around the mean. And I think that Tymar's scores are going to have the greatest standard deviation. His box plot was like way spread out. So that's what I think is going to happen. So each student's data set was nice and symmetric. So the mean is going to be the better measure of center. So our standard deviation is going to be a better measure of spread than that interquartile range. So here's what we're going to do. We're going to determine the standard deviation for all 3 of these. But we're going to walk you through step by step to help reduce the stress levels, all right? So the first thing I want you to do is I want you to determine the mean of Jack's spelling bee scores. Just Jack. We're just going to start with Jack. We'll get to the others later. So start with Jack, determine that X bar value, that mean. Hit pause, work it out, hit play to keep going. All right, I know how to do X bar. I know how to do mean. I'm going to add all of these up and divide by how many there are. She said there was the 10 most recent tests. So I'm going to add all these up and divide by 10. I did use my trusty calculator, and when I added them all up, I got 500. Divide that by 10, and I got 50. Yay! So we found our X bar value. We found the mean of our data is 50 for Jack. Good job, Jack. Now, let's complete this lovely table. So we said that the next thing we had to do is take each individual value, and look, we did a new table and we put them in order. See how we have them in order from least to greatest? Yeah, ascending order. Awesome. And what we're going to do is first, you're going to subtract the mean from each value. So 30 minus, so we said our mean was 50, so we'll do 30 minus 50, which gives me negative 20. So first thing, subtract them all, and then square all of your answers. And don't forget to do the sum at the bottom of the table. So go ahead and hit pause, work all of this out, fill in the whole table, and then hit play to keep going. So I kept going. 32 minus 50 is a negative 18. 33 minus 50 is a negative 17. 35 minus 50 is a negative 15. 49 minus 50 is a negative 1. 50 minus 50 is, well, 0. 50 minus 50 is still 0. 71 minus 50 is 21. 73 minus my mean of 50 is 23. And 77 minus my mean of 50 is 27. And then I squared them all. I squared every single one of them. I squared them all. So negative 20 squared, don't forget when you square a negative, it becomes a positive. So negative 20 times negative 20 gives me a positive 400. When I squared negative 18, I got 324. Again, totally used a calculator, I'm not gonna lie. I squared negative 17 and I got 289. Square of negative 15 is 225. If I squared negative 1, I got 1. Squared 0, I got 0, which happened twice. If I squared 21, I get 441. And when I squared 23, 529, squared 27, I got 729. Now, it did say to do the sum. We don't actually need to do the sum of these guys, but it's interesting to do. If you add all these up, negative 20 plus negative 18 plus negative 17 plus negative 15 plus negative 1 plus 0 plus 0 plus 21 plus 23 plus 27, if you add all these up, you get 0. Oh, what? That does not happen over here. I totally used a calculator. 400 plus 324 plus 289 plus 225 plus 1 plus 0 plus 0 plus 441 plus 529 plus 729. I got 2,938. Now, we need this number. Don't lose this number because we got to do the next step. Now that you have this number, you have this part of your equation, right? You have the whole like sigma, right? And then you had like xi minus x bar squared. This is what you just found. That's this guy right here. You just found that. So go ahead and use the standard deviation formula. You already did the ugly part of it and finish it off. Use this number that you just found, plug that in for this guy for your standard deviation formula and finish it off to find Jack's standard deviation for his spelling bee scores. Go ahead and hit pause to work this out and then hit play to check your work. Yeah. All right. This makes my sigma formula way easier because remember sigma was a big old square root with our standard deviation was this big old square root with that sigma and like the whole like all this guy, right? And then divided by n minus 1. You just did this part on the top. So I'm going to replace that ugly sigma and junk on top with that 2,938. We know what n is because that's the number of terms, and we said there were 10 terms. Wow, this already looks way better. And I don't need a calculator. 10 minus 1 is 9. Now I need a calculator. I don't know. On your calculator, if I do 2,938 and I divide by 9, I get 326.4s going forever. I kept it in my calculator to do that square root and to finish it. And when I did that, I found that Jack's standard deviation was about 18.07. So his mean was 50, but the spread of his data means that he would get about 18.07 over versus 18.07 under. And that was where all of his data is clustered. So that's how spread out Jack's data is. All right, Jack. Now that we got Jack, you know what I'm about to ask you to do next, right? We got to work out Aaliyah and Tamar, right? So, you know how to do this now. We just did a table like this. I would like you to complete the table for Aaliyah and complete the table for Tamar for part A and B, and then we'll keep going from there. So hit pause, fill in your tables, hit play to check your work. So the first thing I realized is I needed my mean. So I needed to find X bar, I needed to find my mean. So I went ahead and I added these all up and divided by 10. When I added them all up, I got 500 divided by 10 is 50. Hey, she is the same mean that Jack had. And now I'm going to do 20 minus 50, 42 minus 50, 45 minus 50, on and on and on. So I did that over and over and over again. And of course, we already, if you add all these up, you will find they give you a sum of 0. Interesting, right? Next step, we needed to square it. So we're going to take all of these numbers and square them. So I did. I squared every single one of them. And then we're going to add them all up. So I added all of these together and I got 1,998. How'd you do with Tamar's step? Did you do his table too? I hope you did his table too. You were told to do both. So again, I'm going to start by finding the mean. So I'm going to add these up and divide by 10. When I added these up, I used my calculator and I got 500 divided by 10 gave me 50. Yay. Now I need to take each of these numbers and subtract 50. So 5 minus 50, 10 minus 50, 12 minus 50, on and on. So I did it over and over and over and over again. I took all of these results. When I added them up to get the sum, I got 0. Figures. And then I squared all of these results. I squared them all. Negative 45 squared, negative 40 squared, negative 38 squared, on and on and on. And you betcha I used a calculator. Please remember, when you square a negative, it becomes positive. Please don't forget that. Remember that negative 45 squared means negative 45 times negative 45. Double negative. Negative times a negative gives us a positive. I added all of these up. It was a lot. And I got 10,388. Seriously, Tamara, that's a serious spread. Serious spread. That's lovely. That's beautiful. Let's keep it going. So now that we've filled in our tables and we've got our sums, finish it. Find Aaliyah's standard deviation. Find Tamar's standard deviation. Go. So we've done the mean. We've done we got to figure out, we calculated our deviations. We've added them up and squared them. Now you got to divide and you got to do the square root. Last step, divide by n minus 1, take the square root. So go ahead, hit pause, finish this off, hit play to check your work. So here we go with Aaliyah. I'm going to take that 1,998. It needs to be divided by 10 minus 1. I know what 10 minus 1 is. It's 9. So I'm going to go ahead and divide these. 1998 divided by 9 gives me 222 exactly. And if I do the square root of that, it's not so exact anymore. If I do the square root of that, I got about 14.90. So definitely a tighter spread than what Jack had, right? Jack was like 18 point something and Aaliyah is sitting at 14.9. Tamar, let's do him. So Tamar, we got up to 10,388. Divide by 10 minus 1. Well, I know 10 minus 1 is 9. So I'm going to divide it by 9. I got 1,154.2s going forever on my calculator. And then use that calculator to do the square root, which got me about, oh my gosh, got me about 33.97. Tamar, seriously? Dude, that's one heck of a spread. So you might want to circle this or have this handy somewhere. You'll be grateful you did. There's just some tips on how to calculate your standard deviation. The order: find the mean, find your deviations, square your deviations, add them together, divide by n-1, and do your square root. So if you have a calculator, none of this is hard. If you have a calculator, none of this is hard, but you might want to circle this or highlight it or take a picture with your phone. I don't know, something. You want this. This is going to help you calculate your standard deviations. Take you step, 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 step. All right. So what can we say about our prediction in question 2? Remember, we predicted who would have the higher standard deviations, who would have the lower standard deviations. And what does this tell you about their spelling bee scores? Hit pause to write down your thoughts and hit play to check your work. We were pretty spot on with our guesses, weren't we? Earlier with our predictions. Aaliyah definitely had the least standard deviation. And that means that her spelling bee scores are more clustered around the mean, right? And Tamar, definitely way to misspell Tamar's name. I'm so sorry, man. I thought that was an A. Tamar has the greatest standard deviation. That was an A. Has the greatest standard deviation. And that means that his spelling bee scores are definitely the most spread out from the mean. They all had the same mean. Did you catch that? But Tamar's was definitely more spread out and Aaliyah's was definitely more clustered together. So which student do you think Miss Webb should add to the spelling bee roster? And again, look at that mean, look at that standard deviation for the student you recommend to justify your answer. Go ahead and hit pause, write it out, hit play to keep going. So they all had the same mean, right? But Aaliyah, she kept it tight, right? Her standard deviation was the least. It was the closest to her mean. So I'm thinking Miss Webb should add Aaliyah to the spelling bee roster, right? All 3 students had a mean of 50. They all had an average score of 50. But Aaliyah was definitely the most consistent. Because her standard deviation was the lowest, she was the most consistent on her spelling bee scores. So I would definitely add her. Jack's was bigger. Tamar's was insane. So I would go with Aaliyah. She definitely was way more consistent than the others. Yeah. So go, Aaliyah, go. Good job. Let's do activity 2.4. Let's do a little more interpretation with our standard deviation. So now we know how to calculate it. Let's dig a little bit more into what it means. We know it means how spread out our stuff is, but let's just kind of take a look at that. The Mountain View High School basketball team has its first game of the season, and Coach Maynard is comparing the heights of the home team's top players to the heights of the visiting team's top players. And we have some lovely dot plots here of our data. So first of all, can you predict real quick who has the greater standard deviation in their heights? Go ahead and hit pause, write it down, hit play to check your work. So if you recall, standard deviation is how spread out things are, right? The bigger the standard deviation, the more spread out your data is. So looking at the data, my home team data is pretty spread out. The visiting team's data is a little bit more clustered in the middle there, isn't it? So I'm going to say that the home team seems to have the greater standard deviation, the greatest standard deviation. Both data sets seem to be spread out the same, right? I mean, 65 to 71, 66 to 71. But I think that visiting team standard deviation is going to be slightly less. Just they have a lot more clustered around the mean than the home team does. Better clustering, smaller standard deviation. So I want you to actually calculate the standard deviation for each team. Yay! And then, of course, describe what this means in terms of our problem situation. And how could this help Coach Maynard? I'm just saying, it could be helpful strategizing for the team. Go ahead, hit pause to calculate each standard deviation and tell us what you find, and then hit play to check your work. I'm going to start with the home team. All right, let's start with the home team. First of all, we have to find the mean, right? So let's find the mean. We got to add all these up. I've got 65, 66, 66, 67, 68, 69, 70, 70, 71, 71. When I add them all up, divide by 10. This is the top 10 members of our team. So I added them up. I got 683. When I divided by 10, I got 68.3. So now that I have this, do you remember what the next step is? I'm going to subtract 65 minus 68.3, 66 minus 68.3, 66 minus 68.3, 67 minus 68.3, 68 minus 68.3, 69 minus 68.3, on and on and on and on. We're going to subtract 68.3 from every single one of those. So I did that. And these are the numbers I got. Next step, they all need to be squared and then added. So I use my calculator. I couldn't even. So I squared every single one of these and then added them all together. It was a lot of work. But when I did that, I got 44.1. Of course, we know 10 minus 1 is 9. That was the nice part. And so when I divided, I got 4.9 exactly. And the square root of that is about 2.21. So here's my standard deviation for the home team. Let's look at the visiting team. 66, 67, 67, 68, 68, 68, 69, 69, 70, 71. So that means we're going to find the mean first. So I'm going to add them all together and divide by 10. I got 683 divided by 10, which is 68.3. Check it out. It's the exact same mean. That's right. We have the exact same mean as last time. So you know what to do next. 66 minus 68.3, 67 minus 68.3, and on and on and on and on and on. So I took every single one of these and subtracted 68.3 away from them. So I did get a few negatives, but it's no big deal because when we square them, we know the negatives will become positive. So again, used a calculator and I squared every single one. And then I added them all together. Thank you, Mr. Calculator. And I got 20.1. Of course, 10 minus 1 is 9. That wasn't the hard part. I divided, and I got 2.23s going forever. Did the square root, and I got about 1.49. So what does this tell us? So this is definitely a smaller standard deviation. We kind of guessed that was going to happen. We already guessed that the home team was probably going to have a bigger standard deviation than the visiting team because the visiting team was more clustered around their mean. So this tells us a few things. So the home team's heights are more spread out. They have a greater standard deviation. They're more spread out. So how could this information help Coach Maynard? Well, if I were Coach Maynard, I would take advantage of the fact that he's more spread out, right? I would try to take advantage of the spread on those heights, right? Make sure my 71 guy is on the 71 guy. And that my other 71 guy is on the 70 guy, right? Trying to make sure that my tall guys are guarding those tall guys and make sure that my poor little guy down here in the 65 end is only with the 66-inch guy because otherwise that could get rough. Just saying. And I'm also looking at these numbers and doing some math in my head and realizing that I'm taller than all of the members of that basketball team. It is what it is, people. As always, I hope you found this helpful. I hope you found this useful. If you have questions or concerns, feel free to let me know. Email me, come see me during office hours, ask me during class. I'm here. And I'll see you guys later. Bye.